This is the lesson you've been probably waiting for. Today we are going to see how modules are encapsulated in code pools and namespaces, and more importantly, we'll start building our custom module. So the list of all Magento core modules is on the left, and if you go one level up, we'll see that all those modules are stored under app, code, core, mage folder. In Magento world, a folder that contains modules is a namespace or package, and it represents the company or organization which developed the module. So we can easily conclude that every module under Mage namespace was developed by Magento core team. And now if we once again go up, we'll see that namespaces are placed within one of three folders: community, core, or local. These folders are called code pools, and basically they separate where all those modules came from. All native functionality is in core folder, and you, as a good developer, should never make any modifications there. It's reserved for Magento core team only. So if you'd like to override core functionality or add a new feature, you need to place it under community or local folder. The rule of thumb is, if you write a module for community, which means you will make it available for download on Magento Connect or somewhere else, the community folder is right choice. Otherwise, if you're developing a module for your project only, stick with local code pool. Because we are going to build a very simple module just for testing purposes, we'll put it in the local code pool under tats plus namespace and give it a name of demo. So let's create that demo folder. Before creating the necessary folder structure, we need to make sure that we have registered our module, so Magento could be aware of its existence. In order to do that, we'll make an XML file in etc modules, because this is where the system first goes in the bootstrap process to find all of the active modules. I'll call the file tats+_demo.xml because I like to use convention name namespace_module_name.xml, but you don't have to. Magento will evaluate all files ending with XML in this folder. It's just a good naming convention. I've noticed there are a lot of pitfalls in Magento naming, and not only for file names, but also for various XML tags in configuration, and for that reason, I will always point out where and why you do have a freedom to give a name whatever you'd like. Okay, so tats+_demo.xml is our module registration or declaration file, which will have a config as a root node. And then to register a module, we simply need modules node. What will happen here is important. Next node name under modules needs to match the folder structure we have in the code pool. So based on the namespace tats+ and module name demo that I've chosen to have, I can simply put the same string here, tats+_demo. And the system will internally convert this value to the corresponding file path. Now the interesting thing that happens is, when Magento sees this node, it will check if the module is active, so we need to add active node. And because we set it to true, it will look for a code pool node. That's why we're adding this, with capital P, which basically says, this module sits under local folder. So after parsing these couple of lines, Magento is expecting to find our module files under local, tats+demo. Hopefully you notice that the whole purpose of this XML file is to register our module and tell the system where it is located, so it can immediately jump there and read the module configuration in config.xml under etc folder. So we need to write another config file, but before that, let me show you how can we check if Magento has loaded our module. I'm already in the dashboard under configuration, system, and then advanced tab. We see that our module is active, and that's exactly what we wanted to see. It doesn't do anything, but it is loaded with the rest of the system, and now we can start implementing our custom functionality. So let's create placeholders for our module's components. We won't need them all right now, but it's good for practice while learning, and as the time goes, we'll be adding file by file in all of these folders. So we'll need etc folder, and config.xml file inside of it. Model folder with capital M as a placeholder for all our model classes. Controllers, the place where we can put all of our controllers. Helper, again with capital H, and I think we didn't mention this folder in the previous lesson. Magento allows you to throw in additional classes that might not fit under MVC letters. We use helpers for declaring utility functions. And of course, I'll create 2 more folders to complete this part. Block and SQL. So far so good. Let's begin by defining a new product model inside of model folder. I'll save the file as product.php. And now, according to naming conventions in Magento, every class name is always composed of the following: namespace, underscore module name, underscore class type, underscore file name where the class is defined. In our case, it's going to be tats+ as a namespace, underscore demo as a module name, underscore model as a class type, and underscore product as the name of the file where we are defining this class. And I'll create a simple function, say hello, which simply echoes hi. We just need something to work with. Now I want to show you a very quick and handy way how can we test our module in a standalone testing script outside of the platform, because we are Magento newbies, we don't want to deal with controllers just yet. So let's keep it as simple as possible and create a new file, which I'll save as test.php under Magento root, and do only 2 things. Require once app/mage.php file. This is exactly what index.php file does as well, because mage.php is a starting point in the system initialization, but instead of calling mage run as index.php does, we are going to call mage app, which basically instantiate whole application and load necessary files, allowing us to play with modules and their classes. Now I can instantiate a new object from my product model, assign it to a variable, and call sayHello method. If you're wondering now why we didn't include the file where the class is defined, and does the system know where to find it, that's a really good question, but let's try it in the browser first to see what we get, and then we'll continue discussion. Okay, so it works. We got hi, and watch what happens when we change the class name to, let's say, product only. Fatal error. Class tats+ demo model product not found in test.php. Okay, we changed the class name to product, so I'll remove everything and leave only product here. Nope, same error. Class product not found in test.php. So in this case, PHP cannot find the class. What happens? The reason why it worked the first time is because of the class naming convention and the Varian autoloader, which is stored under lib_varian. As we already seen, Magento is a huge system containing more than 10,000 files. Including every single file when the application starts would make it extremely slow and heavy. For that reason, Magento makes use of the autoloader class, and more specifically autoloader method, to find the required class each time it is trying to be instantiated. It receives a class name as an argument. In our case, it's gonna be tats+demo_model_product, and then parses it in 3 small steps. All underscores are replaced by white space, like this. The resulting string is ran through uppercase words to make sure all words start with a capital I character, and afterwards all white spaces are replaced by a directory separator, so it ends up with tats+/demo/model/product. .php is appended at the end, and voila, we have a full path which we can include. Let's practice a little more. What if I write something like this? I'll define a customer variable, and assign a new instance of Mage Customer Model Session class. The autoloader will replace all underscores with slashes, so we end up with mage/customer/model/session.php, where mage is a namespace, customer is a module, inside will be a model folder with a file name of session.php. Let's check it. So, mage, customer, model, and yes, here is session.php, so the autoloader is able to include it. That's how it works for models, and you should also know that the same naming convention applies to blocks and helpers. The only difference is in class type. For example, customer, block, account will have the class name of mage, customer, block, account. This block in here is important. On the other hand, I'll go to helpers, and data file will have the class name of mage, customer, helper, data. These naming conventions things are extremely important to learn, because once you get familiar, you'll know exactly where to find any Magento class, as well as where to place your own classes. But if you search Magento codebase, you never find a single expression that looks like this one. Instead, you would see something like this. That's how we actually instantiate a class in Magento, using built-in factory pattern. This is a factory method from Mage class, which will accept a meaningful string, in this case it's customer/session, and convert that internally to mage_customer_model_session, so the autoloader can load that class. Let's try this by calling PHP function getClass on our object. So yes, it really understood that this syntax corresponds to Mage Customer Model Session class. But how it works? And why did we say the config.xml file is a very important, which the system reads as soon as it parses module declaration file? Very good starting questions, and even more reasons to jump to the next lesson and find the answers. See you there!